Let's learn how to name alkenes. Alkenes contain a chain of carbon and hydrogens, and they include a double bond. So the first rule is to find the longest chain, and again, just like what we said about alkenes, longest chain is not necessarily straight. Sometimes you need to turn the corners to find the longest chain. Then if you have a tie in finding the longest chain, like you have more than one way with the same number of carbons, you always go with the most branches. Don't forget, if for example you have 2 branches in one way of numbering and 3 branches in another way, you choose the one with the 3 branches. The second rule is to number the carbons. We always, after we find the longest chain, we number. And how to number? You always go with the closest to double bond. If you have a branch and double bond, then, and you have a tie, like the 2 carbons from double bonds and 2 carbons from a branch, in a tie, you will go with branch. Closest to branch. I mean, you go with this side with the branch. Like for example, to give you an idea, if you have CH3, then CH, CH, and let's say CH, Cl, and CH3. You see, from left to right, carbon number 2 gets the double bond, but double bond will be between 2 and 3. And from right to left, the second carbon will get chlorine. So 2 and 2. In this case, you will start with naming the chlorine first. By the way, when you are numbering the chain, or let's say the longest chain must include both of the carbons in double bond. Okay? So 1, 2, 3, 4, and 5. And you always number the double bond by the number of carbon that starts double bond. The third rule is to indicate the carbon of double bond. In a minute, I'll show you with an example. Then number four, identify name and number of branches, the substituents, like are they methyl, ethyl, isopropyl, what are they, and on which carbon, and write the name as one single word, again between hyphens between letters and numbers, and listing the substituents in alphabetical order, like di, tri, tetra. You will have them in your chapter. And for cycloalkenes, you number the carbons in the ring. So carbons of double bond is between between 1 and 2. So like, let's say for cycloalkanes, C1 and C2 must be for double bond. I give you enough examples. And what else I can tell you about it? And also halogen and other substituents don't get the priority over the double bond for the bricks. So let's work on some examples that you already have here, each 3. So I will work on C and D. Alright, so the longest chain including double bond. So the longest chain, you might say, okay, I have longest chain is 1, 2, 3, 4, 5, and 6. But does it really include double bond? No. The longest chain is this that includes double bond. And I start from left to right because that's closer to double bond. So double bond has priority to the branch. So What is the name of our substituents? This is ethyl and this is methyl. So first we number and name the branches. There's a 2-ethyl. What else do we have? A methyl on 4. And it's time to mention the location of double bond. That's the difference between alkenes and alkanes. Where does the double bond start? On the first carbon. And how many carbons do you have? 5. If it was an alkane, it would be pentane. But this is an alkene, so this is pentene. Shows alkene. Be careful about the ending. The second example is going to be what you have in part D, what we talked about when we were talking about cycloalkenes. We have 2 choices. First of all, we have to, it's not the matter of ring anymore, because it's not the matter of the longest chain anymore, it's a matter of ring. But your double bond carbons must be carbon number 1 and 2. You have 2 choices, going clockwise or counterclockwise. If you go clockwise, you will have 1, 2, and the first branch is going on to be on the 3rd carbon, and the 4 and 5. But if you go, excuse me, if you go on the ring counterclockwise, 1, 2, 3, and 4, this is not correct because you're not including the 2 carbons of double bond. If you go with this carbon, 1, 2, 3, 4, 5, then the first branch is going to be on the 4th carbon instead of the 3rd carbon. So seems like clockwise numbering is the correct numbering. It gives our branch the smallest number as possible. So we have 2 methyl groups on the 3 and 4. So it's 3 and 4 dimethyl. What else do we have? We have cyclopentene. So we don't have to mention 1 here because we already know by default that carbon number 1 is the carbon of double bond. So it's just cyclopentene. Okay? Now, working on some more examples on page 4. You're supposed to give the IUPAC names. So, I'm working on B and C. It's a little bit too early to work on OH alcohols, but you already know how to name them. You will have them more in organic too. So for B, first of all, we are supposed to find the longest chain that includes double bond. So let's see. 1, 2, 3, 4, 5, 6, 7, and 8. Now, something here is that OH has priority to double bonds. So you will need to start from the end that gives OH the smallest number. If you start from here, 1, 2, 3, 4, and 5 is OH. Here, 1, 2, 3, and 4. So you need to start from this side. 1, 2, 3, 4, 5, 6, 7, and 8. So far, I just learned that OH has priority over alkene. That you don't have any more functional groups at this point. That's enough to know. So let's see what we have. We have an ethyl group here. We have a methyl group here. And we have an ol here. OL for hydroxyl group. So we say we have an ethyl, alphabetical, 5 ethyl, 6 methyl. then 7. If it was an alkane, it would be octane. Now it's octene, but we eliminate E because we haven't taken care of all yet. Octene, 4, all. It's a very special type of naming at this point. Don't get confused if you have any other functional groups besides double bond. But basically learn here that if you have OH, then OH has priority in numbering when you get there, but obviously all is after octane. So you start alphabetically with the substituents, 5-ethyl, 6-methyl, and then 7-octane. If this is octene, then if you did not have anything else, it would be octene and an E. But since you are supposed to continue with an ol on the 4 carbon, then you need to eliminate E. That's the rule. That's the IUPAC rule for naming. C is a good practice on if you have more than one double bond, what happens. So you start from closest to the first double bond and branch. Seems like it doesn't matter from which side. So 3, 4, 5, 6, 7. Either way, the first branch and double bond will fall on the second carbon. So we have 2 methyl groups on 2 and 6. So you have 2 and 6 dimethyl. Okay? And now you have 2 double bonds on where? The starting point for the first double bond is carbon number 2. Starting point for the second double bond is carbon number 6. So it's 2 and 5. How many carbons? Hepta. If it was 7. If it was an alkane, it would be heptane. But it's hepta. How many double bonds? Diene. So if you have more than 1 double bond, you will end up in like propa, buta, penta, hexa, hepta, octa, nona, and then diene or triene. Okay? These are 2 different rules that you just learned by working on these 2 examples. Okay, let's move to name the stereoisomers. Just reminding you about what you had in stereochemistry. Not very new, you already know some stuff about them. Do you remember cis and trans? Okay, that's my watch. Alright, so you remember you had cis when you had 2 hydrogens, invisible hydrogens, and you have 2 groups on one side, it was cis, right? And this one was hydrogens on 2 opposite sides and 2 groups on the opposite sides. It was trans. Now we can name them now. These are the carbons, right? So 1, 2, 3, 4, 5, 6. Now naming them makes more sense. So this is 6. You can either say 3 hexene, or you can say cis hex 3ene. This is a newer way of naming, but both of them are correct. Either you say 3-hexene means double bond is between 3 and 4, or you can say hex and then dash a number where the ene is located. Either way is correct. And this is obviously trans 3-hexene or trans hex 3ene. I just write one of them, but both of them are acceptable. Okay? Now, what if instead of hydrogen, here I have chlorine? What happens? What if not 2 of the groups are hydrogens? So we have to use another way of naming, which is called E and Z. We call them EZ, and they're really easy. Diastereomers. You remember diastereomers? They are not mirror images, and they are different in their chemical and physical properties. So there are 3 rules. Let me draw this and explain it on this one. There are 3 rules that you already know them. Do you remember the priority on the groups? These rules, priority of the groups, remember we used to find them by atomic number. So now on each carbon of double bond, we need to choose the priority of the groups connected to each carbon of double bond by the atomic number. So carbon has higher atomic number or hydrogen? Obviously carbon. On this carbon on the right side, carbon has more atomic number or chlorine? Obviously, if you check with periodic table, chlorine. Okay? So the first priority is with the atomic numbers. So now this is when the 2 prior groups are on 2 opposite sides. You see, you don't have a hydrogen here. You cannot call them cis and trans. Now you call it E and you put it in parentheses. E is similar to, equivalent to like trans, but it's used for when you don't have hydrogen, 1 hydrogen on each carbon. You have more complicated groups. So you call it E and you go ahead and number the same way that you learned and name it. So 1, 2, 3, 4. 1, 2, 3, 4. We start closer to the chlorine. 1, 2, 3, and 4. So it's called E. Where is chlorine? On the second carbon, 2 chloro and 3. I'm sorry, 2. What did I say? Double bond is on 2. 2, 1, 2, 3, 4. Butene or butene. So one more time, when the groups are on opposite side, prior groups. On opposite sides, you call it an E. But suppose that you have such an isomer. This is the same, but chlorine comes on this side now. So now the 2 prior groups are on the same side. Such an isomer is called Z. Since this is the same exact compound, the name is going to be the same. Z, 2 chloro, 2 butene. So you use Z, very similar to cis, when prior groups are on the same site. Z. E and Z come from 2 German names, Zusammen and Entgegen. Don't worry about their names, and you just learn E and Z. E when the prior groups are on 2 opposite sides, Z when the prior groups are on the same side. The second rule for priority, if you remember, was when the atoms, the immediate carbons atoms are the same, we go further until we find the difference. For example, rule number 2. Like when you have CH2, CH3, and just CH3. Let's say carbon is CH2, CH3, and here you have CH3. So which one has priority? Carbon, carbon. Another carbon, but 3 hydrogens. So this group has priority. The same thing for the rest of the groups. So you go further and further until you find the difference. And finally, the rule number 3. If you have, say, double bond another element, another atom, it looks like as if you have carbon connected to two oxygens. So you can tell COH has higher priority than CH2OH. Why? Because CH2OH is like CH2 and OH, right? And here COO. So carbon connected to 2 oxygens, carbon connected to 1 oxygen. 1 oxygen versus 2 oxygens. 2 oxygens have higher atomic number than 1. I mean, not atomic number, but higher priority. So, if you want to work a little bit more on the groups, on page 5, you have, let's work on, how about, let's work on A and C. CH2OH. You have Cl, CH3, CH2, CH3. So, carbon, carbon. 3 hydrogens, another carbon. So this is the prior group. We are supposed to find E and Z in this practice. Carbon, chlorine. Which one has a higher atomic number? Chlorine. Both of the prior groups are on the same side, so this is a Z. Work on C because this is different, and most of the students get stuck when they see a ring here. I'll start with this carbon on the right side. So what is connected to carbon on the right side? COOH. That's the, you need to be good at functional groups at this point. CO2H is COOH, the carboxylic acid. So it seems like carbon is connected to 3 oxygens, 2 here, 1 here. All right? And then here is CH2OH, 2 hydrogens and 1 OH. So which one has priority? 3 oxygens versus 1 oxygen. 3 oxygens for sure. For the ring, as if like you have 2 separate groups. Carbon 2 hydrogens, carbon 2 hydrogens. You go around the ring until you find the difference. Carbon 2 hydrogens, carbon connected to another carbon. So as if like this side of the ring is prior to this side. So this is another Z again. So one more time for the rings. You go around the ring until you find the difference. Carbon 2 hydrogens, carbon 2 hydrogens. Carbon 2 hydrogens, but carbon with another carbon. So it seems like the half top is prior than half bottom. If you did not have this CH3, the 2 sides will be the same and you cannot assign Z or E. But now CH3 is the tiebreaker. Okay, that was a summary on naming the stereoisomers and working on nomenclature of alkenes. Preparation of alkenes, 3 main methods. One of them is, you already know it, alkyl halides, when you use elimination reaction. So NaOCH2 CH3, a bulky, strong base, right? And you have a secondary alkyl halide. We're supposed to use what we have learned in the previous chapters. Now, what happens? you need to apply Zaitsev rule if it is applied, and use the, form the alkene. The second one is dehydration. If you have, let's say, this is a tertiary alcohol. Dehydration of alcohol. This is an alcohol. Dehydration is normally done by heat and acid. So you will end up having an alkene. Secondary and tertiary alcohols go with E1, so tertiary. And primary alcohols go with E2. The third one is also using an alcohol using POCl3 pyridine. You will learn the mechanism for this reaction in organic. You will deal with a lot of mechanisms in organic too. So you need to apply Zaitsev rule whenever it is applied. So E2 reaction happens. So if you want to work on the two examples here, dehydration by an acid, and be careful, you need to apply the Zaitsev rule. The most substituted alkene will be produced. Which one is the most substituted alkene? Of course this one. 1, 2, 3, versus if you wanted to form it here. So second one, bromine, and you are using a big bulky base and a secondary alkyl halide. So using elimination reaction here, Zaitsev rule doesn't matter. So you put the, actually matters. So here you have less substituents, here you have more substituents. So don't forget to use Zaitsev in all of these are elimination. So you need to work on these, know which one is used for each of the alcohols, alkyl halides, and the reagents. So work on these until you are ready for working on the reactions. You have the real feel of organic chemistry now.